In this video, we will see how to convert Grasshopper and Rhino data to OWL and RDF representations, including semantics and geometry. To achieve this, we're going to use GraphDB, bhOWL, and BHoWL, and in the following, I'm going to show you how to install each of their respective softwares. So we're going to start with GraphDB by Googling GraphDB and navigating to their website. Then we can see in the comparison table that GraphDB comes in two versions, a GraphDB free version and an enterprise version. For our purposes, the free version is going to be sufficient. So enter your details, and on the next page you'll be prompted with a download link for the OS that you're using. So next, let's continue with bhOWL. Again, we're just going to Google bhOWL, and we're going to choose the first website that shows up in the search results. And here you can see we have two options, view on GitHub and the download link. Then you can click the download link and you will also be redirected to the GitHub page where you can learn more about the project. After the download is finished, just open up the exe file, and it will take a moment and you'll be prompted with this Windows warning, but we can just circumvent that by clicking on more information and then run anyways. After that is done, we can navigate to the GitHub page, and here, in order to install RDF, we're going to search in the repositories for RDF and click on RDF prototypes. And here on the top, we can see the wiki button. We're going to click on that. And here there's two options to navigate to the download, installation, and update instructions. And here we can see that we've already completed the first steps by installing bhOWL. And in order to install bhOWL, you also want to close all instances of Rhino, XL, and Revit. So to download RDF prototypes, we're going to navigate to the releases and click on the online installer. Unzip it, and in here you can see two files, and we want to run the online installer. And we get the same prompt as before. And after we click run anyways, a command window will pop up, and this will fetch the most recent release from GitHub, download all the files for you, and show you if the installation was successful, and then we can just press any key and we're done. If at a later stage you want to update RDF prototypes, you can just run the installer again and it will fetch the latest release for you. So now that everything is installed, we can get into the actual process of using the plugin. So here I have a simplified model of the Farnsworth house by Mies van der Rohe, built in 1951. And we're going to use this as an example to show off the plugin. So we're going to start Grasshopper, and here I've already extracted some basic geometry based on the 3D model that we had. So for example, I have extracted a curve that describes the room, and also some more curves that describe the ceiling and floor plate, and some points where I actually want to have some columns. So in order to build the graph representation of our 3D model, what we want to do is convert this geometry into bhOWL objects. So to bring up the bhOWL menu, we can press Ctrl, Shift, and B. So we get this prompt bar, and here we can type in room, for example, and see the different search results that come up for room. And we can see that there is an acoustic namespace and an architectural namespace. And we want to select the room object that has a curve perimeter and a location point. So now we can hit enter, and we get a component on the canvas that has three inputs: a perimeter, a location, and a name. And our perimeter curve is going to be the curve that we've gotten from our Rhino model. And for the location, we're going to use the curve again by leveraging the area component in Grasshopper and getting a centroid from the curve that's going to be our input point for the location where the room is. So now let's move the ceiling out of the way and also give our room a name. And we're just going to name this room main room. So let's move this to the side and plug this in, and our room object is done already. So now let's do the same thing for ceiling as another example. So we type in ceiling again. You can bring this menu up by pressing Ctrl Shift B again. And let's navigate. I think the ceiling looks right. Let's hit enter, and we get a ceiling component on the canvas. And for this, we're actually going to use the curve again, where we're going to leverage the surface component and plug in the surface into our ceiling component. So let's move the other components out of the way for now. And we see that our ceiling component still has more inputs, for example, construction. And the nice thing that we can do is we can just drag the wire in the opposite direction and release the mouse button, and it will prompt us with different inputs that might be able to be taken by this component. So in this example, we want to look for construction. So we can take a construction component and place it on here. So again, let's move this out of the way, and let's also give our ceiling a name. So this is probably the equivalent to the room. So this is the main room's ceiling. Let's plug that in. And I'm going to do the same thing for the floor really quickly. So we have our floor. So let's also do this for the columns. Let's space these out. And for the columns, it's going to be a bit more interesting. We can again press Ctrl Shift and B and search for column. And we want to select the physical element column. And we want to look for the one that has a base point and a height and a frame. So let's press enter. So we're going to use the points that we extracted from our columns as the base points for this column component. And for the height and the other properties like name, I've already prepared some things down here. So let's plug those in. Okay, so what we can still see is that there is an input missing from our component. So we can utilize the same trick that we used earlier in the ceiling, and we just go back, drag the wire back, and we can select the framing property. And we see that this component takes in a profile, a material, orientation angle, and a name. And we're going to do the same thing as before, and we're going to use a material. I think this is the wrong material though. So this material component then again has a name, density, density options, and properties. So for our columns, we want to use S235 steel. So let's plug that into the name. And the density, I already looked this up, is around 8 tons per cubic meter. So let's plug that in. And we can see that our framing property is still missing a profile. So I've already prepared that as well. So we're going to use a HEA 100. So let's also put that into the name of our framing property. Let's plug that in. And now let's use the same framing property also for the columns that we have in the main building as we've used in the yard. So now that we're done with converting all the geometries that we had from our Rhino model, I've taken the liberty to group these a bit. And we might still have some information left that is not necessarily represented by the geometry of our model though. So for example, the architect, when the architect was born, or where the building is located. So what we can do if we don't find, for example, this architect component, we can come up to the BHoM tab here, and we can see that there's also a component called create custom object. So if we drag this on the canvas, we see custom object and objects as an output. But if we zoom in, we can hit this plus icon here and we can add different inputs to our component. So for example, we could rename our component building and use this component to summarize all the information that we have about the building. So let's name the first input, for example, name, and we can plug in the Farnsworth house. And let's name the second input year of construction. And when naming these inputs, it is important to not use space characters because this will mess with the formatting of the files and GraphDB will not be able to read your file properly. So either you can use it like this, just write it as one word with upper and lowercase, or you can use underscores to separate the words as the input. So let's also add a site location here, and this time we're going to write it with underscores, and we're going to plug in the site location. And let's add a fourth input. And this time we're not gonna just input a string, but we're actually gonna input another custom object that I've prepared here, which is the architect. So we can plug a custom object also into another custom object. And this one I just renamed architect and given it two inputs, name and the date of birth. So in this case, it's Mies van der Rohe. And we can just plug that one in as well. So lastly, we can also use this custom component to combine all the different objects that we have in our building now. So this is what I've done here now. I've added the rooms, the floors, ceilings, and columns. And what I lastly want to show you here is that in the case of the columns or in the case of the floors, we have multiple inputs. So when we plug those in, what we want to do is we want to come to the input and we want to right click and we want to hit list access. So all of these different inputs are not being considered as multiple buildings, but all lead to one object. So let's hit list access and you can see that the 12 objects that we had before in the building component now change to one building. So after we've constructed our building object now, what we want to do is actually visualize this building in GraphDB. So in order to do this, we can come up to the BHoM menu again. And in the adapter section, we're going to utilize the push component. So we're going to drag that onto the canvas. And here you can see the push component takes in objects as an input, which we can just plug in the building object that we've created. And it is also important to plug in an adapter. So we can hit Control Shift and B again. And here we can just search for the GraphDB adapter and we can select the first one. So we're going to plug this into the adapter. And both the push component and the GraphDB adapter also have a active input where we're going to plug in a Boolean toggle, and we're going to leave those on false for now. So now if we double click the Boolean toggle on the GraphDB adapter, what will happen is that it's going to search for the exe of GraphDB and is going to try to start up GraphDB on your machine. So this will take a few seconds. And after GraphDB is done starting, a browser window will pop up with this screen. And here we can see our active repository, which has a total of 921 statements. And if we come back to Rhino and Grasshopper, we can see that if we change the object input to our push component, so for example, let's take this single room and plug it in. And we come back to the browser and we refresh the page. We can see that now our total statements have changed from 921 to 236. So the objects are also live updated in GraphDB. So let's plug in our building component again. And let's refresh again and we see that the total statements has changed again to 921. So we can navigate GraphDB by this panel on the left side, and most of what we're going to do is happen in the Explore tab and in the SparkQL tab. And in the Explore tab, we can click on Graph Overview and we can look at our default graph. And here we have everything that we've input from Rhino, but also some inferred knowledge that GraphDB has inferred based on the data that is there. So here we can see our triples. We can see subject, predicate, object, the different classes and individuals that are in here, and the relations. And if we want to come back to the main page, we can click on this GraphDB icon, and then we are back to the starting screen. So let's come back to the default graph. And we can sort the subjects. So maybe we might want to visualize the column object or the room object that we had earlier. So let's click on the room here and we can copy directly the URL to our clipboard. So one option to visualize this object now is to come down here to the visual graph. And here we can paste the URL that we just copied and click on show. And we will see our room object with all the related data. And we can now collapse and expand different data entries that are connected to our room object. So another powerful feature that GraphDB offers is SparkQL queries. If we come to this tab, we can see our saved queries, and we can see 5 different icons, and the fourth one is especially important, and this turns on and off inferred data on the results. And we can see, if we come back to our active repository, we have a total of 921 statements, and 461 of those are explicit, and 460 of those are inferred by GraphDB based on the relation that the data has to each other. So now if we come back, what we can do is, for example, a construct query. We have all our prefixes and the constructor query down here. And if we turn off the inferred data, we can again see that we have 461 statements. And if we turn inferred data on, we can see that we have again our 921 statements. So this construct query up until now constructed the entire graph, but we can also make it more specific what we actually want to query. So in this one, we have another construct query that only selects classes that are of the OWL class. And if we now run this query, we can see that there's 24 statements. So another thing that we might want to do is do a insert query. So in this, we have already data, but we want to modify it and add more data to it. So in this example, for example, we want to add a construction company with the prefix URL of the construction company to our graph. And if we click run, we see, okay, one statement has been added to the graph. And if we come back to the main page, we also see that the total number of statements has changed from 921 to 922. And if we do a construct query of the entire graph again, we can also see that the statements have changed. So the last query I want to show you is a delete query. So of course, maybe we also want to not just add information to our graph, but maybe also remove information. So a good way to do this is to come to the graph overview, and then we can look at the subjects and pick out an individual that we want to delete. So in this example, I'm looking for a column. So first off, I'm looking for the physical column object, and I'm going to copy its URL. So what we can do with this URL, now we can search for all the entries that relate to this URL. And here in this context, what we can do is we don't want to look for subjects, but we actually want to look for an object. And here we have all our column individuals. So I might just want to pick one of those and copy its URL. And after that, after we've copied the URL, we can then come into the SparkQL tab again. And in our delete query, we can input the URL that we just copied to delete that exact individual. So now with this statement, if we hit run, we can see that 6 statements have been removed from our graph. And if we come back to the main page again, we see that the total number of statements has also changed to 908.